Hello? Hey. Hi everyone, thanks for coming. This is a talk called Underwhelming Game Development with PICO-8. Going to do some kind of intro. This is a talk. Hi. I'm Jonas. I'm here because programming, I think. Not always sure how I end up places. Probably something like that. I am employed by my employer. I usually forget to say that, so I've written it down. The slides are very bad, and I'm sorry about that. I'm usually bad at making like regular slides. This time we're within PICO-8, so we have fewer pixels and they're worse than usual. But I've tried to make like an agenda. We'll do some introduction. We're doing that right now. We're going to talk about what PICO-8 is. We'll have some kind of demo. I'm going to say that I like Lua. It's a nice programming language. And we'll take a look at some cute sort of programming problems. And yeah, I saw some other slides had a point about business value, so I added that at the end. And then I looked at the agenda, and it's probably not going to be like one demo in the middle. Maybe like demo and Qt problems are kind of cross-cutting concerns. Usually cross-cutting concerns means logging, but I think that a demonstration can be a cross-cutting concern as well. So something like this. But also I don't like bullet points that much. And they tend to communicate that this is a structured thing that happens in a particular order. And it might go something more like this. We'll do some intro, PICO-8, demonstrate the tools we can use in PICO-8, talk about Lua, the system, maybe some syntax. Closures are really fun. I'm sort of considering if I should complain about functional programming being more fun 10 years ago than it was now. I'm going to show that I can't draw. I'm going to show that I can't do sound effects. Write some bad code, which I think is good. Probably get distracted. Lua is still cool. And now it sets kind of rustness value or something. But there's an up arrow and a cat, so you can ask like, what's up, cat, and press the up button and crash the slides. And crashing the slides is good because then you can, oh, this is the wrong thing. Then you can go to the code that contains the slide, and you can fix the slide. And we can, yeah, so business value is back. We also want to kind of get across that these things are connected in different ways, so we want to add some lines here. That's a lot of like, what's it called? Time, uncertainty, and change going on. Let's look at the line function. There's lots of draw some random lines. We can seed the random number. So now you can see that things are connected. They could be connected in different ways. So we'll do like, now you can pretend that different colored lines mean different things and the topics are connected. I think this is a pretty good agenda. This sort of gets more across sort of the structure of the talk, I think. So I guess the most important thing is sort of trying to see what it's like to stay within PICO-8 for a while, seeing what it's like sort of jumping between running programs and coding them and trying out the tools, coding some stuff. We'll try not to learn anything too important. It's supposed to be kind of underwhelming. It's late. We don't want to do like software engineering. So this is PICO-8. PICO-8 is a fantasy console. It's made by someone called Sepp. Sepp is the short name for someone also known as Joseph White. I'm going to say Sepp. Yeah, so PICO-8 fancy consoles. There's a good talk by Sepp called PICO-8 and the Search for Cozy Design Spaces. I would recommend people watching that talk instead of this one. He goes into a lot of the sort of the philosophy behind the design decisions. I tried to put the URL in here, but you probably can't read it. URLs are case sensitive, which is kind of awkward with this font. So you're better off just searching for the talk title, I think. I have some quotes during the talk that I've stolen from that talk. Yeah. PICO-8 is actually paid software. If you want like the full system, it costs like $15. The games made are typically free. There's also a free web version that has most of the features, but can't like make cartridges and some stuff like that. And I think there's like open source implementations of sort of the engine that runs games, and Sepp is cool with that. So, I think he wants to kind of hold on to PICO-8 as a thing that is not this open source thing that is forked in different directions to sort of keep a consistent aesthetic and stuff. But I think he wants software made for it to live on. Yeah, he says in the talk that fancy consoles are impressionist hardware. By that it means it's not actually hardware, and you're not actually sort of building a console and solving real-world engineering problems. You're building a virtual machine, and you're putting a bunch of constraints in, and the constraints are about sort of making it feel a certain way to work with as a coder, as a developer, and also sort of giving the games made a certain aesthetic. And there's a bunch of stuff about sort of the stuff that makes a console interesting isn't necessarily only the hardware, it's the sort of culture that surrounds it, the tools you get to use for building software for it, the way it acts as a distribution platform. So stuff like PICO-8 sort of tries to get at that without actually building machines, I guess. So PICO-8 is one fantasy console. There are a lot of different things in sort of the same space. Some things are not necessarily called fantasy consoles or fantasy computers. But yeah, Sepp has made a couple of different ones. There's one called Voxatron, which is like voxel graphics instead of pixel graphics. And there's a new one called Picotron, which is similar to this, but a bit larger. This thing is like 128 by 128 pixels. Picotron, I think, is like more similar to having an Amiga or something, and this is kind of maybe more similar to having a Game Boy or something. Yeah, there are others made by others. There's one called TIC80, which is pretty similar to PICO-8, but open source. Puzzle Script is often mentioned sort of in the same breath, which is cool because it's built for making a certain kind of games, like Sukoban-like puzzle games, and it has its own programming language for expressing rules about basically pushing boxes on a tile map. There's one called WASM4, which is a sort of WebAssembly thing, so you can write in any programming language and compile to this engine that will run, and it includes stuff like netcode for you, so if you sort of target that platform, you can play multiplayer online. And there's one called the Varvara, which is made by some French people on a boat in order to make their software more portable and require less power and stuff like that. It uses a Fort-like assembly language, and they build their own tools on that. Yeah, so it has a bunch of specs. These are the PICO-8 ones. Pretty small screen, 16 colors to choose from. You can build like cartridges that are actually like image files, PNG files, in order to distribute something that sort of looks like a real thing. It has a 4-channel synth. There's some limit on the number of instructions per second. That's like Lua virtual machine instructions. And I think you have like 2 megabyte heap space. And while you're building games, you can use your mouse and keyboard and stuff, but when you are playing a game built with it, you have like a 6-button controller in order to play the game. And it has built-in tools for everything you need, so you can make you can write code within PICO-8, and you can draw your graphics and make your sound effects and make maps and stuff like that. So 128 by 128, the idea being that it's as small as possible without being too small, I guess. Most games that you might be interested in making, unless it's like 3D stuff, I guess, should be possible to fit into that space as long as you don't care about sprites being tiny and stuff like that. 32K cartridges. We can actually take a look at that. If we can save this as a PNG file, and then we can open the folder. You see, you get an image that looks like this, and within the PNG file, it includes like all the source code and stuff. So you can load this PNG file in PICO-8 and play the game. We can press F7, I think, and overwrite it. And then you get like, let's zoom in. So you get this image file that you can give to someone, and it looks like a cartridge, and they can kind of plug it in their PICO-8 system and play it. You can also there's also an explorer built in to check out published games, and you can publish it on like their web forum and play it in the browser and stuff like that. There's a 4-channel synth. I think each like sound effect uses 64 bytes, 2 bytes per note and some metadata. So I have just a few bits for each piece, and we'll look more at it later. But again, it's simple enough so that you can probably make something that sounds okay within those constraints without knowing too much music stuff or anything. It's the same system more or less for music as it is for sound effects. You just play them slower, and then it sounds like music instead of like a blurb. And from the talk, in the talk, he mentions that he's not trying to like capture a distinct moment in history. He's not trying to work with the constraints that make like sense in the 80s and 90s or something. And the constraints that come with PICO-8 are pretty understandable to sort of regular programmers. For instance, the palette, we can take a look at it. Some great drawings. You have these 16 colors. You can use all 16 colors everywhere. There's not like weird stuff like if you program for a Nintendo 8-bit, you'll run into stuff like, and then each individual sprite has a palette of its own because it only wants to use like 2 bits per pixel or something. You usually don't run into stuff like that. Similarly, you can, when you paint sprites on the screen, on a bunch of old hardware, you have stuff like you get to have 8 sprites total. In PICO-8, it uses this many cycles, and you spend sort of the universal resource for that. So you usually mostly care about like how much memory you are using and how many cycles you are spending. So a bit about Lua. Sepp is kind of concerned with cuteness a lot of the time. So he thinks that the Lua virtual machine can be thought of as a little animal that is working away, chewing away at instructions, running our code. And it's tiny, so we like to think of it as cute. I mostly included it so I could include a Dijkstra quote. Dijkstra says that, it's a difficult word, but anthropomorphizing inanimate object is, in science, a symptom of professional immaturity. I'm going to say that we're sticking with Sepp here. We're not doing science. We're pretending that Lua is an animal. Anyway, it's nice. It does a bunch of high-level language things, and it's tiny. So it compiles to a couple of hundred of kilobytes, and Lua sort of supports this live programming system, a runtime that can load code on demand. It has some convenient stuff, like it's fully garbage collected. There's some fun object stuff you can do. There's a lot of fun closure stuff going on. And it has some sort of cool features related to being a scripting language that is meant to be embedded in places. So it's easy to load foreign code and shut off features of the language, or shut off, or only give it access to like this part of the standard library. In PICO-8, they use their own standard library, so we're not using like the sort of mainstream Lua standard library here. But it's suited for this kind of thing, basically. Also easy to restrict it, like only give it access to this much heap space, or make sure it doesn't run too many instructions and stuff like that. Yeah, and one thing I like about it is that it doesn't feel too modern. I think it's made, the first version of Lua was like in 1993 or something. So a lot of the syntax stuff, yeah, we can take a look at it. I wrote an up button here again so I can crash the slide. And yeah, what was I gonna say? Let's see, it crashed here. And yeah, it uses like, it's a kind of keyword heavy syntax compared to some languages, so it uses end a lot. And if you, let's write some code here. So you can do stuff like, let's fill the screen with something. So it uses like, in for loops, it uses for, and then it uses do, and then you have to finish with end and stuff like that. It doesn't use curly braces for control structures. You use curly braces to make tables, which is sort of the universal data structure in Lua. So we'll print something. Another fun thing about PICO-8 is that the font includes some, like a cat and stuff like that. And we can print it at some position. Let's do n plus 10 and do some. Yeah, in the update function that is being called this many times each second, we are incrementing a by some value. So we could do something like this, and then absolutely can't do that. I'm probably, yeah, this isn't where I should write the code. In the draw function. Let's see, and give it one of the colors. So this is color 10, it says. Yeah, that seems nice. But the syntax is kind of old-fashioned, and I think it's nice because it feels like a different place than you know, IntelliJ or Visual Studio or something. You feel like you're in a different space, writing something that's weirder than what you're usually writing. Okay. Yeah, so I was going to be grumpy about this. I'm not going to be super grumpy because functional programming is a lot of fun. But there is this thing that when I first started looking at Lisp and stuff like that, most of what I liked doing was just being really stupid with functions and throwing closures around and carrying state around and doing stateful stuff. And these days, there's often a focus on everything you're not supposed to be doing with functions because they stop being mathematical functions if they're stateful and stuff like that, which is useful if you're doing like proper software engineering, but sometimes software engineering sounds like less fun than what you want. So a thing I liked about Lua in general is that it feels natural to do things with closures. And it's not a functional language, and you usually do like stateful things within functions. So like one of the things is that I showed one for loop that was like incrementing one number stepwise. If you want like your custom iterator for a for loop, you can make a function that just every time it's called, it returns the next value that you're going to for loop over. Yeah, we can just take a look at it. Let's see. I can show you first. So for, let's see, x, y in screen, do print x, y. So for looping across, let's escape that. Passing in some function, and the sort of for thing just calls the function it received over and over until it returns nil, and you evaluate the block within the do and the part every time. So we can take a look at this screen. So the screen function is a function that initializes some local variables, and then it returns a function, and this is the function that is called over and over by the for loop. I coded it in an attempt to be straightforward. Once y hits the end of the screen, we start returning nil. We store these x and y values so we can return them later, and then we try to increment stuff. We could probably do it in a smarter order, but I haven't. So we increase x by 1. If x hits the end of the screen, then we set x back to 0, and we increase y by 1. So we can do that maybe some for x, y in screen, do. And we can do something like we'll set a pixel at x and y, and we can choose a color for it. There are 16 colors, so we're going to modulus 16, and we can try x plus y. And it looks like this, easy to read. I think it's more fun if we multiply them, because then it gets like more circular. So we get these nice patterns. And yeah, the thing I like about it is that sort of building this screen function is fairly lightweight thing to do. You just make a function that returns a function, and just deal with returning the values you want from that function. I suppose we could try to make it more readable again, but it's not much better. Yeah, so some impressions so far. PICO-8 is a space. It's presumably cozy since Sepp said that. And I think a nice thing about it is that you kind of have everything you need inside here for the kind of things you can use PICO-8 to build. I find that if I'm playing around with PICO-8, I don't need to sort of look up stuff all the time in a web browser or alt-tab to some other program and things like that. You can usually sort of jump between coding and running programs. And it's natural to set things up so we get like feedback on things pretty fast, and it runs immediately. It also has stuff like you can get like documentations on the different functions it supplies. from within the system. Yeah. So here's the snake game. It's not very good, but we can play it. So yeah, so this is the part where I guess we're just looking at some code and trying to do stuff. Let's see, this is the snack tab. I'm not sure how many tabs you get by the way. This is sort of the amount of code organization you can do. Seems you can add a bunch of them. Yeah, so I put the code sort of within the code for the slides. So there's usually one more level of nesting than you would have in sort of regular PICO-8 code. Made some helper functions for making vectors. So I use have a vector type that can have an x coordinate and an y coordinate. And let's see here. This is the function that kind of makes the slide that contains the game. And then it has an update function. Yeah, I want to uncomment that if I want to be able to move to the next slide later. Yeah, this is the update function, so this fires like 30 times each second, I think. We have a delay, so every fifth frame we want to do something. So we increment t by 1, and then we check if it's equal to the delay, and in here we sort of move the snake in the direction. PICO-8 comes with some global variables. So if you don't, we can do print. So this is sort of the key code for the up button, but in the code there's a global variable that looks like the up button and the down button and stuff like that, so you can use that in your code. I have made some global variables for vectors for the different directions. So here we move the snake in a direction. We want to do something, let's say, do some refactoring. So we have a position, and then snake equals p, and it still runs, and it does the same as before, but here we can do something like, let's see, there's an apple over here, starts at this vector. We have made a function that creates a new apple, which we can use when we eat this apple. So if p is equal to the apple, then we'll add p to the snake. That didn't do much. I think, do I know how this function works? No, I don't. Add p to the snake. Yeah, so that looks pretty good. We make a new apple. This is basically snake now. Disjoint. Yeah. So it grows longer and longer. It doesn't follow the rest of the snake. We can try to do something like, if we start, so this hash thing is like length, so take the length of the snake. So if e equals snake, and lists in Lua are 1 indexed. So let's go down to let's say we want to copy something to the tail of the snake from the position before it, and so on down to the second position in the list, so before we reach the head of the snake. We deal with the head of the snake on this line here. So I think we can do snake e equals snake e minus 1. That's pretty good. It's more or less a complete snake game, I think. We can maybe add a sound effect. I'm not sure which. That sounds more like eating, doesn't it? So SFX, I think that was the first one. So Lua is like one indexed by default usually. I don't think SEP likes that, so a lot of Pico things are zero indexed anyway. So this is like the zeroth sound effect. Oh, that's nice. 8, 10. What else does snakes can run into their own tails. So you can try to add that as well, I think. I'll have to try to keep track of time as well. I didn't prepare that part really. This is the part where we run through the snake, so we can probably check for it there. If the position we're moving to is equal to snake E, then we're dead. And we return, and we can do something over here. Okay, let's make it a local variable so we don't stay dead after a restart. When it falls, let's see, if dead, then return and this is like the one bit where I took notes for everything, and then I thought, oh, maybe if we have time, we could try making it crash into itself and code that bit. So this is the part where I just give up if it gets too hard. It's probably not a good idea to. Okay, let's do something maybe extra ugly here. So I'm an idiot, so I just added this position here to the end of the snake, but it's going to be overwritten by the sort of correct position by copying from its tail closer to the head anyway. But I probably run into this in this loop. Maybe I can just check later. Yeah, much better. Yeah, and I rotated. I turned in the opposite direction, so I immediately crashed and died. That's good enough. Let's just, if dead, then print something. Uroburo dead. Yeah, that's a full game. Yeah. We can release this. I'll put in the slide controls again so we can move to the next slide. So yeah, you've gotten some impression of the code editor. It's small. You can fit 32 characters in a line. I usually stick with 31 because I think this is what it looks like with 32, but then it starts scrolling because it needs another space for a character to show the cursor. So I usually leave it like this so it never scrolls for me. But that's sort of a fun constraint on its own, I think. There's something about tabs versus spaces that is really nice because you don't want to use more than one space anyway because you have so few of them. So I'm not sure if I hit tab, it does one space. If I hit space, it does one space. I don't know if it actually uses tab characters or not. Okay. Yeah, good enough is kind of within reach. And by that I mean that if you look at games other people make, they draw fantastic stuff within these constraints, but it still feels okay to draw something kind of shitty, and sort of blame the constraints. You only had 8 by 8 pixels, so it's not going to look too good. And you not feel like you sort of have to learn how to draw stuff. You don't have to become like a 3D modeler or take an education or something. Making some sounds and making some graphics is within reach. For coding stuff too, I think that you don't have to, like, if something is really sophisticated and impressive and you're not sure you can do it, it's probably not a good fit for PICO-8 anyway. Maybe you can sort of blame that if I was going to make this massive graph of objects and do collision detection, I would probably run out of memory, so I'm not going to bother. I'm going to do something simple instead. So it's kind of freeing at that. I used it myself earlier on. I sort of excused myself by saying, yeah, I'm bad at making regular slides, but these slides are going to be particularly bad because I have so few pixels. And obviously, I could have put more effort into it, but it feels okay within this environment to do something kind of half bad or sort of argue that, okay, but within these constraints, it's good enough. Another thing, I think Sepp says it in his talk, but it's kind of not a game engine in the sense that it gives you everything you need to build a game. It has tools for stuff and some building blocks and API functions that you probably want for games. And it does help you with some game loop stuff, like you write the update and draw function, and sort of the machinery takes care of calling your functions enough times each seconds for things to work out. But it doesn't, for instance, handle collision detection. There are other stuff that you sometimes expect to find in a standard library, like sorting a list. It doesn't have a function for that. And altogether, it's like fairly agnostic with regards to what type of game you can build with it. It doesn't give you a bunch of tools that only are suited for making shoot-'em-ups or making platformers. And I think that when you look at the games made by other people, there are like different sort of action arcade games like platformers and shoot-'em-ups and stuff, and a fair amount of puzzle games like Sukoban-like sort of tile-based puzzle games. And yeah, since you don't have like libraries and stuff like that beyond copying what other people have done, the idea is that you do sort of the game programming yourself, and you get to solve some fun problems doing that. Okay, some more tools and stuff. Here's a game. I can move it to I can press. I put it there and thought I could press up to crash it, but apparently I removed that. But that's the cat game. So we should probably put a cat there to begin with. Okay, so it's a cat. I promised in the abstract that I was going to draw a cat, so we're going to do that now. So this is the pixel art editor, and this is what a cat looks like. Cats have eyes. It's better the other way around, I think. And cats have mouths. And they have bodies with legs. Yeah, I promised being bad at drawing stuff. I think this looks okay, though. So instead of printing a character, we can use the sprite function to draw the cat, which says it's sprite 18. Okay, that's a cat. Let's see. See how much time we have. Yeah. Yeah, we can try to do some mild platforming stuff, like making it possible to jump or something. It's a cat. It has a position. It starts at vector 2020. We can make some states. It can fall. It can jump, and it can be on the ground. And we're going to say that those things are functions. So if the cat is falling, then cat y is cat position is cat position plus this down global variable. Cat state is falling, and we'll do something in the update function. Cat state. Yeah, so now the cat is falling. It's going to stop falling at some point. So if the y value, it starts at 2020. Let's say that if the y value, let's just be straightforward and say once it's fallen to 30, then cat state is ground, and function ground does nothing. Okay, so that's nice. Let's see. We have some additional buttons we can use. So when it's on the ground, it should be able to jump. If we push the button, no, those are the two non-arrow buttons. Then let's see, cat state equals jump. And let's make a jump function. Function jump. Cat p equals cat p plus up. Okay, it jumps. Bye, cat. Okay, so this is. It's on. I only wanted to jump like a certain amount of stuff. So if we do like I equals 1, and then we want to use that I as state, so we probably want to return a function. So this is the fun part, is that you always solve things by sort of putting functions within functions. At least I do. So if I is 10, then cat state is fall. I equals I plus 1. It's not jumping at all. Yeah, now I'm returning a function, so when I'm jumping I should call this function so I get the return function as return the function as its state instead of just its jump function that doesn't do anything on its own. That's not a very tall jump. Let's do 20. Yeah, it's good. We should make a new sound effect, obviously. This is sound effect 1. Yeah, that was music instead because I had accidentally turned the speed up. Yeah, that's a sound effect. That's kind of jumpy. And so when it jumps, well, we're calling it the jump function when it jumps. I was going to put it in the ground function when you push the button, but you can probably put it here instead. That should be the next sound effect. This is extremely video game. Let's see. Yeah, we can quickly take a look at. There's a map editor as well here. So I have like some badly drawn terrain. I'm also bad at drawing the terrain onto the map. Let's see, can I just flood fill the rest? And where's the draw function? Here it is. So I think there's a function called map txtysxsyt. Okay, whatever. The ones with W and an H are probably how much. Let's try something like that. Oh, I like this. Yeah, because I removed the clear screen thing because I thought the map was going to... I was kind of uncertain about sort of how much time I was going to spend on things, but I realized I can just jump around here for 10 minutes if I'm doing bad or good on time. Maybe I should do the clear screen anyway. Yeah. And at this point, you could do stuff like use functions like mget, which wrong button, which checks a square of the map and see what tile it is, and check the terrain to see if it collides with terrain. Let's instead say that it has to. Okay, that's not. Yeah, that's pretty good. So again, a full-fledged video game. Slides control. And we're back to the slideshow again. Yeah. Yeah. So again, in Sepp's talk, he mentions that he likes that it forces you to confront like cute problems. So I wanted to talk like at least 5 minutes about that. Like the direct quote is like how to fit your data in. But the idea is that often since you don't have like every function you expect from like a full-fledged sort of game engine library, you have to deal with a bunch of stuff, and you have some building blocks, and you tend to get some ideas about how to do stuff. And if you're lucky, they're like fun ideas that make you explore things like you wouldn't have explored anyway. And you get to do this sort of mildly computing science stuff. Like someone has probably written a paper about it in the 60s, but you can do it badly today and sort of not solve the general solution or not making it scale and have fun with it. So yeah, let's maybe look at the actual cat game. So the game I'm working on, which is called Cat and Yarn, which you can find in video game stores anytime now. Yeah. This is sort of Sukoban. Sukoban is the game where you push boxes into the places they go. This is Sukoban with one addition, which is that some boxes move sort of all the way until they hit something when you push them instead of moving only one square. So you have to sort of. And I made this piece of music as well as all the graphics. The graphics down to the left look particularly bad, but yeah. I'll just play. I don't have many levels, so I'll just play through it so you can see all the sort of graphical effects and things I'm using for it. But yeah, I think this is the penultimate one, and this is the final one. this is where I didn't bother trying to make it difficult. So here comes the graphical effect I made for when completing the game. So now I have to decide between letting it run like this for 10 minutes or actually showing some of the cute problem stuff I was talking about. Yeah, okay, that's enough. So I think we can start over. When you make a Sokoban game, the first thing you do is to make things move like instantly one-on-one squares. So like I do this when I undo moves, so you see it just moves instantly to the next square. But I wanted to have like an animation where you see the cat moves its legs a little and stuff like that. So I think that's the closest thing I had to like a cute problem that I got to solve was like, oh, I need to build an animation system. So we can take a look at, let's see, where's the update function? Update. So I have an animate function, and if it returns true, then I don't do any of the game logic stuff. So the game is either sort of animating that the cat is moving or something, or it sort of responds to input and you can make your next move. So when I push a button, it does like 8 frames of animation, and then you can push a button again. And the animate function, let's see. Yeah, so see here, it has a result value, and it returns the result at the end. And the way I made it was that if there was anything to animate, then it returns true, which means that it's animating and not doing game logic stuff. So if this one is set to true and return later on, then you will not be able to move the cat during the same frame. And when there is nothing left to animate, then it will go back to responding to input again, and you can make your next move. So it goes through anims, animations, which is like a hash map where each thing, like a cat is a thing, ball of yarn is a thing. When the cat wants to do an animation, it adds itself to this hash map, so the cat is the key, and the function that animates the cat is the value. So you get the thing and the animation function. And the only thing we do is to call the animation function. And let's see the other setup here. I think, nah, I'm not. Okay, bunch of code. Land. This is horrible. So for the jumpy, when you complete a level, the cat gets jumpy and it bounces around and moves through the air. So you see what they do is the cat adds itself to the animations list and adds this function. And each time it is called, y is increased by 1. And every now and then it makes a sound. And it calls the function jump gfx. And once y hits 50, it removes itself from the animations map. And I think this just does random stuff, like. So what I did was I made this thing where when I want to do an animation, I can sort of throw a function into the sort of animation map or animation dictionary, and when it's done, it will remove itself. I'm still not sure if that was a good idea or if I should have returned false or something instead, but it's small enough so I can change it later. And then each thing, like the cat, for instance, has this object with some additional graphic properties. So the cat is at some position in the board, but it also has like offset values for x and y, and and if it wants to be flipped horizontally or flipped vertically, you can set these left and up values. And let's see in the draw function. Oh, this is horrible. Yeah, let's not spend too much time on it. But in the draw function, you pick up these values. So if I have an animation function that increases some x's and y's, then this is picked up later when you draw it, and the cat can move a bit up and move a bit down when it moves, and it can jump all over the place up when it goes up. And it's probably a bad solution to the problem, but it's good enough because the game is tiny, and yeah, it doesn't need to scale beyond what I'm doing. So you get to sort of solve these problems without thinking about, is this going to scale to what the business is doing in 10 years and stuff like that. And you can have a pretty good time. And I think that's mostly it, business value now. And I don't really like. Yeah, I think this is fun, and I don't really like to devalue it by arguing that it's also useful. But it's probably not bad for you. It's wholesome. You can't do AI with it. It has 2 megabytes of heap space, so you can't put an LLM there. And that's nice. And it's an environment where I think it feels natural to set things up so that you get feedback really fast. When you're working on graphics and animation, you want to see it move immediately. And sort of Lua and fast compilation times and all that stuff works for you, and you see the value in getting fast feedback. And I think that's, it can at least be a good reminder. It's sometimes you forget that when working on your sort of day job, that seeing what it's like to use some code you've written and what it feels like, and getting that feedback fast is, at least to me, pretty useful. Yeah, cats are cute. And that's it. If questions or anything, I'm around, and you can come and punch me in the face if you want to, or ask me questions. Okay, bye.